Okay, welcome to Math Grade 12. So, we'll be doing Mathematics Paper 2 for 2020. So, this paper has been downloaded on setpastpapers.com. So, for reference, you can go and download this past paper. So, if you've not been exposed to past papers, this is page 1. Okay, it has got instructions. Page 2 has got formulas. And page 3, that's where things start happening. So for 2020, question 1, okay, was as follows. So given that the matrix A is equals to 5, 2 to x, find the value of x for which A has no inverse. Okay, and 2, the inverse of A if x is equals to 3. So for this particular video, we tackle question 1. A and B. Okay. Okay, so question 1, how do you tackle question A? So the value of A when the value of A when for which x has no inverse. Okay, so how do you tackle that? So when A has no inverse, okay, has no inverse, then the determinant of A is equals to 0. Okay, now how do we find the determinant? So the determinant of A for any particular matrix, so let me just write a general matrix here. So suppose A was equals to A, B, C, D. Okay, then the determinant of A, okay, I just say determinant of A would have been A multiplied by B by D, so it will be A D minus C C B. So this is how you find the determinant. So in this case, applying this formula here, this would be 5 multiplied by x minus 2 multiplied by 2, which will give us 4. Okay, and then we equate it to 0. So when we solve for this one, put x aside, we would have x, 5x equals to 4 over 5 over 5. So x is equals to 4 over 5. Okay. So this was for question 1. For question number 2, so for question 2, we are saying we find the inverse of A when x is equals to 1. So how do you find that? So our A here is equals to 5, 2, 2, 1. So where there's x there, I have replaced, we have put 1. So how do you find the determinant? So going back to our example here, suppose that we have A is equals to A, B, C, D. So we are saying to find the A inverse. So A inverse is denoted as A to the power negative 1. So this would be equals to, this would be equals to 1 over the determinant of A. Okay, determinant of A multiplied by, now where there is A, we are putting D, and then we multiply negative C on the minor diagonal, you multiply by negative, and then you swap the major diagonal. Okay, so this is the major diagonal, this is the major diagonal, and then this is the minor diagonal. So you swap the major diagonal, the values on the major diagonal, and then you multiply negatives on the minor diagonal. Okay, so using that concept here, we are saying A inverse will be equals to 1 over the determinant, okay, over the determinant of A okay, and then we will swap the values as 1, 5, -2, -2, like so. Okay, so now what is the determinant of A? So determinant of A would be equals to 5 by 1, that is 5 minus 4, this will give us 1. So this would be 1 over 1 multiplied by 1, -2, -2, and 5. So this will give us 1, -2, -2, 5. So this is how you work out question 1A. So for B, on probabilities, how do you find how do you tackle this question? So for B says a bag contains 7 red, 3 white identical balls. So 2 balls are taken from the bag at random, one after another without replacement. So the key word here to note is these bags are gotten without replacement. What does that mean? It means that you have got balls, 10 balls, 3 white and 7 red. So you are getting a ball without replacing, meaning that the sample space is reducing every time a ball is drawn. So we are told to draw a tree diagram showing all the possible outcomes. So this one is particular easy. So to draw a tree diagram, you start with a starting point, a dot, like so, and then here we have 2 possibilities. When a ball is drawn, it's either red or it's white. So now here, what is the probability that it is red? So there are 10 and then there are 7 red. So the probability that it is red will be 7 over 10. Okay, so the probability is that it is white, it will be 3 over 10, because there are 3 white balls and there are 10 altogether. So we are saying 2 balls are taken. So this is the first ball. Okay, so the first ball can be either red or white. So suppose that the first ball is white, what will be the second ball? So the second ball could be either white or red. So it can be red or white. Okay, so if the first ball was red, meaning that the red has reduced by 1 ball and it becomes 6, and the sample space here will be, instead of 10, will be 9. So here we are going to have 6 over 9, and then the white balls, because we haven't drawn any white ball, okay, yes, so it will be 6 over 9. And then if the first ball is red and then the second one is white, so the probability will still be 3 over 9. So red W. So if the first ball is white, the second ball would be 7. Okay, because we didn't draw a red ball, so over 9, and then this one would be 2 over 9. Okay, so this is how you draw the tree diagram. So for question 1, this is how you draw the tree diagram. Question number 2, find the probability of taking at least 1 white ball. So the probability of taking at least 1 white ball. Okay, so just continue with our mathematics here. So here we have red, here we have red, white, here we have white, red, and then here we have white, white. So the question is telling us to find the probability of taking at least 1 white ball. So at least 1 white ball, so meaning that this one qualify, that one qualify, that one qualify. So now the question is, what is the probability of so this one would be equals to the probability of getting a red, white plus the probability of getting white red, and plus the probability of getting white. Okay, so now this would give us what is the probability of red white. So the probability of getting red white, we are multiplying 7 over 10 by 3 over 9. Okay, so this will give us 21 over 90. Okay, and then the probability of getting white red would give us white red would be 3 over 10 by 7 over 9. So this will give us again 21 over 90. So the probability of getting white would be equals to 3 over 10 multiplied by 2 over 9. So this one will give us 3 times this, which is 6 over 90. So adding all these possible outcomes, we have 21 over 90 plus 21 over 90 plus 6 over 90. So 21 plus 21, that is 42, plus 6, okay, plus 6, that will be 48 over 90. So 2 there, that will be 2, 4 over 2 into 90, that will be 45. So we have reduced. So this is the probability of getting at least one white ball. Okay,